This portal represents the starting line of your 14-day AI sprint. By the end of today's session, we are going to unpack the architecture of large language models, build a meta prompting engine, run models locally on your own hardware, and eliminate AI hallucinations using Retrieval Augmented Generation, or RAG. Mastering this material requires a strict commitment. You need to block out 4 to 5 hours every single day for the next 2 weeks. There are no shortcuts. We divide your daily time into 2 distinct phases. First, we cover the foundational theory in a detailed lecture. Then, we immediately move into breakout rooms for hands-on execution using dedicated workbooks. The only way to transition from a casual AI user to an actual AI builder is to show up every day, embrace the intensive structure, and put in the work. This diagram shows exactly what happens the moment you submit a prompt. The AI doesn't read English. As your sentence enters the system, it triggers the first chronological phase of processing. We call this step tokenization. The model shatters your input into smaller fragments and assigns a specific numerical ID to every single word and punctuation mark. Next, the model assigns meaning to those numbers through embeddings. The tokens are converted into multidimensional vectors. Words with similar meanings are mapped closer together across this mathematical grid. Then comes self-attention. The model evaluates the entire numerical sequence to determine which specific words matter most. It isolates the critical context of your prompt and ignores the filler. Finally, the system arrives at prediction. Using all of that weighted context, it calculates the single most probable word to output next. These models do not possess intelligence. They are highly advanced statistical engines, recognizing complex patterns and predicting reality one token at a time. Because models operate purely on probability, treating them like a casual chat window guarantees poor results. You get accurate outputs through structured context engineering. This matrix outlines the 4 strict pillars of a perfect prompt. First, you assign the AI a specific role. Second, you provide the background context. Third, you define the exact task. And fourth, you set rigid constraints on the output. Writing these manually for every problem is slow and inefficient. Instead, we use a technique called meta-prompting, where we instruct the AI to architect the perfect pillar-compliant prompt for us. We do this by uploading the official prompt engineering guides published by companies like OpenAI and Anthropic directly into Google AI Studio. We then instruct the model to synthesize those guidelines into a single master prompt. Once you run this workflow, you stop guessing how to structure your requests. You state your goal, and the AI autonomously engineers the optimal instructions for any future task. Notice this data flow here. When you use public models, your information leaves your device and travels to external servers. If you process confidential corporate data this way, you are actively creating a major security risk. The solution is running local large language models. By hosting the AI directly on your own hardware, the data never connects to the internet. Because the model runs on your machine, it requires significant processing power. Your computer must have a minimum of 8 GB of RAM to handle these offline systems. We manage this through a software environment called LM Studio. This application allows you to securely download and operate powerful offline models, like DeepSeek or Meta's Llama, entirely on your desktop. Local deployment grants you absolute data sovereignty. It is the only secure method for processing enterprise-grade confidential information. Even with a secure model, you face the problem of hallucinations. This occurs when an AI confidently fabricates facts or details it was never actually trained on. This split screen illustrates the cure: Retrieval Augmented Generation, or RAG. Rather than letting the model guess from a chaotic void, a RAG system forces the AI to retrieve answers directly from specific documents you provide. We implement this using tools like Google's Notebook LM. You upload custom PDFs, and the software establishes those files as a strict, exclusive knowledge boundary. Think of this system as a highly disciplined personal librarian. When you ask a question, it scans your specific files and only generates an answer if it can cite the exact text. The AI is no longer a blind guesser. It functions purely as a reading comprehension tool, neutralizing the risk of hallucinations and delivering outputs you can trust. Today, you built a highly practical toolkit. You know how to deploy Notebook LM for RAG systems, configure LM Studio for local data privacy, and engineer master instructions through meta prompting. Step 1 is to apply this immediately. Take the course transcripts provided today, upload them into Notebook LM, and build your own personal AI mentor. This rendering previews our next milestone. Tomorrow, we focus heavily on the visual capabilities of AI, walking through the exact mechanics of generating your own photorealistic video clones and digital avatars. Today, we laid the invisible architectural foundation. Tomorrow, we use that foundation to build highly visible, scalable AI creations. See you in the next session.